6.1, graphing systems of equations. There are going to be three types of solutions. One of them is no solution. The other one's infinitely many solutions. And the last one, which is the one that we'll use the most, is one solution, and that will be in the form of an ordered pair where you have an x and a y answer. Okay? Let's get started. So, two or more linear equations together are called a system of linear equations. We will be solving these systems three different ways. The first thing we're going to do this PowerPoint in this slide is graphing. But the other two ways are called substitution and elimination. We'll work at those all separately. But today we will be solving by graphing only. In order to graph these equations, they must all be solved for y. Okay, and you guys have gotten really good at that. We've practiced enough. Or, solving for y is also called that slope-intercept form, which was the y equals mx plus b form. Okay? Doesn't go away. Make sure you know those words. The graphs of these lines will do one of three things. Okay, they are going to cross only at one point, or they're going to never touch, or they're going to be on top of each other, and it really will be the same line. So let me show you what we're going to do. Let's start with this. Now remember, when we're graphing, and we have it in y equals mx plus b, okay, we always begin with b. Begin with b. All right, so in this problem right here, remember it's y equals mx plus b. B in this problem right here is going to be 4, so we're going to start with 4. Now, b is the y-intercept, which means it's on this axis. So, on this axis, where is it? Positive 4. Right here, so you put a dot. From there, we're going to move, I'm going to write it above here, move with m, which is your slope, okay? And our slope right here, what number is really with that x? A 1. So our slope would be 1 over 1. It's positive, it's 1 over 1. So from here, we're going to go up 1 and over 1 and put a dot. Okay, we can go down 1 and over 1 and put a dot. And I would suggest putting several because you're going to need a line that's going to extend, because with these things you're going to have longer lines in order to see where they might intersect. All right, so you keep on going and then draw your line. Now you're going to have two different lines on here, so you need to make sure you can see them both. If you're not using a pencil and you start messing up, this is going to where using a pen is going to drive you crazy. So you need to find those pencils with the erasers in case you haven't been using them. And I'm giving that shout out to Caleb Hart because he doesn't seem to own one. So Caleb Hart, find a pencil. All right, so the graphs of these lines, like I said, are going to do one of two things. They're either going to cross, never touch, or be on top of each other. All right, so from here, I've got the one line graphed. I have to do the second one on the same graph, not another page, but the same graph. So again, we'll start with and begin with B. So I'm going to get a different color. Now, if you want to use, color pencils or whatever, that's fine. I just suggest that you do something where you can erase it. All right, so the B on this one is 1. So I'm going to put a dot on 1. And this is where you really need to use graph paper. If you're trying to make your own paper and mark little hash marks, it's not going to be exact and your answers are not going to be correct. So please, please, please use the graph paper or the boards or whatever I give you so that they will be accurate. Okay, don't try to make your own grids. All right, from here, the slope on this one is m is -2. So that's -2 over 1. So that means I'm going to go down 2 and right 1. It's very important that you're graphing correctly. Down 2 and right 1. I can also go up 2 and left 1, up 2 and left 1, and draw your line. Okay? Now, notice that these two intersect right here. This point right here is the intersection, and that would be at point -1, 1, 2, 3. So that should be -1, comma, 3. That's the location. -1 is my x. 1, 2, 3, +3 is my y. That's why you got to make sure you have these in the right order. Remember, x comes first, then y. And what that means is if you use -1 as your x and 3 as your y and plug them in here, that would make this equation equal both sides. And that will also work for this one. Those are the only two numbers specifically that will work for these two equations. Okay, so the intersection is our answer, -1, 3. So when we're doing these problems, you're going to have to make sure they're solved for y. You're going to have to graph both lines correctly, and you're going to need to find the intersection. So there's a lot of parts to each one of these problems, but they're very easy to do. And you can check your answers with your calculator. So I'll pull that up for you. You go to y equals, turn it on. Go to y equals, and I want to type in x plus 4. Okay, so x plus 4, and go down to the second line and type in the other one, -2x plus 1. And I want to graph it. And you can see that is the intersection. Now, if you want to know that point right there, there's a way we can do it. We do second trace. Second trace, and we want the intersection, which is number 5. Second trace 5, you're going to hit enter, enter, enter 3 times. And look what it tells us. Our intersection is x -1, y 3. So you will have to be able to graph them on paper, and you can always check your answers on your calculator. But you need to be able to do both. Okay? Check your work. All right, so the next one, let's practice graphing with our calculator and graphing with our graph paper. We begin with our b. Our b is 1 on the first equation, so I'm going to put a dot at 1. And then my slope on this one is -2 over 1. So I'm going to go down 2 and over right 1. Down 2 and over right 1. I'm also going to go up 2 and over left 1. The opposite of what I just did. Okay, because it needs to all be on a line. And it needs to be a longer line than just a couple dots. You don't draw it out, it's not going to be able to see where your intersection is. All right, I'm going to change different color. And this one I'm going to begin at 4 and put a dot. Whoa. Let's try to get this a little bit better and look there. 4. Big dot on 4. And then my slope on this one is also -2 over 1. So I'm going to go from here down 2 and over 1, down 2 and over 1, down 2 and over 1, and draw my line. Whoops. Now, if you'll notice, they have the same slope. Okay, same slope. And notice what happens when they have the same slope. It will never intersect. They are parallel lines. Parallel lines never intersect, so that means there's never going to be a solution, because solutions are only when they cross. So the answer to this one is no solution. Okay, no solution. Make a note. Parallel lines have the same slope. Same slope will always be no solution. Okay? So if you get to this and you see that that's already the same slope exactly, then you don't have to do any more and just write no solution, unless I ask you to graph it. All right, and then the next one, it says y is equal to negative 1/2 x plus 2. And then, oh my goodness, this one's not set up right. We need to solve it for y, which is good practice. We need to practice that often. All right, so let's find my little pen. All right, there's my pen up here. I'm going to write it up above here. X plus 2y equals 4. All right, to solve for y, we need to move the x first. We've learned that and done that a million times. X has to go first. So subtract x, subtract x. That leaves me with 2y equals minus x. I told you always, always, always put the x first. Plus 4. Divide by 2, everything. Okay, so now y is going to be, in this particular problem, what number really is in front of that x? A 1. So this is now really a negative 1 over 2x plus 2. All right, so I'm going to change that down here and write y is equal to negative 1/2 x plus 2. Okay, and I'm going to erase this and get this out of the way of my graph. Okay. All right, so here's my first equation, negative 1/2 x plus 2. Here's my second equation now, negative 1/2 x plus 2. Well, heck, these are the same exact line. All right, so let's go ahead and begin on B. That's at 2. Put a dot. And then I'm going to go, my slope is negative 1 over 2. So I'm going to go down 1 and over 2. Down 1 and over 2, and draw my line. Okay, I'm going to get a different color. Okay, this one is also starting at 2. I'm going to go down 1 and over 2 also because it's the same slope. And notice these two lines lay on top of each other. That's because they are the same exact line. All right, so make a note, same line. That means there will be infinitely many solutions. What that really means, that infinitely many solutions, any number will work. So if I use the order pair 0, 1, it would work for both problems. If I use negative 3 million and negative 4 million, that will work for both problems. It does not matter because every single pair of those order pairs will work for both problems because it's the same line. So same line will have infinitely many number answers. Parallels won't have any, but if they cross, which most of ours will do, and that's what we'll be working with the most, you must find that intersection, and that is your solution, and it is only one solution, and that's the ordered pair that you will have to find. Okay, next one. All right, so remember, we begin on B and we move on M. So let's practice doing a couple of these. Let's see if these two, what they will be. All right, I'm going to look. They're already solved for Y. That's good. So then I begin with M. So let me talk about M and B again. Remember, this is our peanut butter and jelly sandwich. We have to know what they are and do what we need to do with each one of them. On the first problem, what my B is the 2. And my M is 3/4. Because I'm using Y equals MX plus B, which is the slope-intercept form, which is right here. All right, so I begin on B, which is 2. 2 is always on the Y. So I'm going to go 1, 2, and put a dot. Then I'm going to move on my m. Go up 3 because it's positive, and then right 4. So I'm going to go 1, 2, 3, 1, 2, 3, 4, put a dot. Okay, I want to probably go the opposite direction too, just to make sure that my line is long enough. So I'm going to go 1, 2, 3, 1, 2, 3, 4, put a dot. Draw a really long line. Okay. All right, get a different color or a color pencil or whatever. Now this is 2x minus 3. All right, so I'm going to begin at negative 3, and my slope is 2, and we'll put that over 1. That means positive. All right, so I start at negative 3, which is down below, 1, 2, 3. And I'm going to go up 2 and over 1. Up 2 and right 1. Up 2 and right 1. Up 2 and right 1. It didn't darken very well. Whoops. That doesn't look like a dot. It looks like a smudge. Up 2 and over 1. Up 2 and over 1. Up 2 and over 1. So you really have to keep doing this until your lines cross, if they're going to cross. Draw your line. All right, so it appears that I have one solution because it intersects 1, and that solution is going to be an ordered pair. All right, let's figure out what that ordered pair is. What's that location of that dot? Well, it goes 1, 2, 3, 4. 1, 2, 3, 4, 5. So that appears to be 4, 5, which means x is 4, y is 5. So 4, 5. So if you had to pick them out, you could always, if you had ordered pairs, you could always plug them in and see if they work, if they make each side equal. 4, 5. Okay? And you can graph it and check also. You want to do that? Let's check that really quick. Make sure this is on. Go back to y equals and clear those out. All right, let's make sure these work. All right, so the first problem was 3 over 4. Let me do this with my hands. 3 divided by 4x plus 2, and then go down and type in 2x minus 3. Okay, and graph it. Make sure it looks like your graph. You can zoom in or out with the window. We'll practice that in class. But it does intersect. We want to find the intersection. You hit second, trace, and the intersection is 5. Second trace 5. Enter, enter, enter. And it will tell you the intersections at x is 4, y is 5. So we did that one right. Okay? All right, let's do the next problem. So this one is not in y equals form, so guess what we must do first? Solve it for y. So I'm going to put it up here so you can see x plus y equals negative 3. Remember, when we're solving for y, x has got to go first because it's alphabetical. All right, so that leaves me with y is equal to negative x, always put that first, so you'll be ready to graph, minus 3. Okay, so I'm going to go ahead and put that down here. Y is equal to negative, and I'm going to put a 1, x minus 3. So my m is negative 1 over 1. My b is negative 3. Okay? And on the next one, it's already solved for y, so I'll go ahead and separate my peanut butter and jelly. All right, so my m is 3 over 1. My b is 5. Okay, so now we're ready to graph. All right, so I'm going to begin with my b, and my b on my y is negative 3. 1, 2, 3. My slope is a negative 1 over 1. So that means I'm going to go down 1 and right 1. Down 1 right, down 1 right. Or going to go up and left, okay? You want to make sure that it's long enough that it's going to intersect, so draw your line. That is probably my best one ever. It will never happen again. All right, it just won't. All right, so now the next one is B is 5. So I'm going to start on my B, begin at B, and go 1, 2, 3, 4, put a dot. Whoops, 1, 2, 3, 4, right there. All right, and then my slope is a positive 3 over 1, so I'm going to go up to 3 and over 1. But I'm also going to go backwards, down 3 and left 1. Down 1, 2, 3 and left 1. Okay, so at least I can see where I'm going to intersect. All right, then draw a line. Okay, so it appears that I have one solution. Let's write that over here, one solution. And it's an ordered pair. What's the location of that point? Let's see, it goes 1, 2, negative 2 is my x, and down 1, which is negative 1. So my solution on this one is negative 2, negative 1. Okay, and again, you can check these with your calculator. Go and plug in y equals negative 1x minus 3 and 3x plus 5. Graph it, and then second trace 5, enter, 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 and it will tell you that this is the solution, okay? So always check your work. All right, so then we're going to graph these. Now this is a really good problem because it says x is equal to 6. Now, when we have an x equals to 6, I can tell you right now, your calculator is not going to do that for you. So you're going to have to exactly know what the heck that means. So, M is, B is, M is, B is. All right. Okay. What is x is 6? That tells me it's on the x-axis. So where is x6? It's on this direction. 2, 4, 6. I'm going to put a dot. But I'm not done because that's just a dot, not a line. This is an equation. That's a dot. So I have to draw my line. I do not have a y in my equation, so that means it cannot touch this at all. So that means it has to go vertical. Now, what's my slope? Okay, this is what kind of slope. That's right, you should know this by now. Undefined slope. Okay, what's my b? Did it cross the y-axis at all? No, so that would be none. All right, make sure you have that or there will be little pictures of puppies marked through. All right, so on this one, what is my m? 3 over 2. What is my b? Negative 5. Let's change colors. All right, so my b is negative 5. That's where I begin. 1, 2, 3, 4, 5. Put a dot. My slope is positive, so I go up 3. 1, 2, 3, and over 2, right. Up 3 again, over 2, right. Up 3 again. 1, 2, 3, over 2, right. And draw my line. All right, so it appears that we do have an intersection. All right, that means it's going to be one solution, and that solution is an ordered pair. My x coordinate is going to be 6. And how many did I go up? 1, 2, 3, 4. Right there. Whoops. Let's get a color you can see. Do this first. Right here is your solution. Right there. Where it intersects. Okay, so that's at 6, 4. All right. Looking at this problem, it is not solved for y, so we're going to go up here and work on that problem first. It says 2x minus 2y equals 2. Remember, when we're solving for y, x has to go first because it's alphabetical. Mark through. That leaves me with negative 2y equals negative 2x plus 2. X got to go in the front on this side. Dividing everything by a negative 2, and this is where you really got to watch your signs. That'll leave you with y is equal to, because this goes away, negative 2 divided by negative 2 will make a positive 1x. And 2 divided by negative 2 makes a negative 1. So that's my equation right there. So I'm going to go put that over here. Y is equal to 1x minus 1. My m, my b. M is 1 over 1. My b is negative 1. Okay, looking at this equation, I don't know what that little mark is. Just ignore it. It's just y equals x plus 2. So m is equal to, b is equal to. M is going to be 1 over 1. So there's a 1 right there. My b is 2. All right. Now, let's graph these. I am going to start with my first one is at b negative 1. That means I am going right here. And up 1 and over 1. Up 1 and over 1 to the right. And I can also go down and left. Down and left. Okay, the other one is starting at B, which is 2. I'm going to put a dot at 2. And my slope is up 1 over 1, up 1 and over 1, up 1 and over 1, down 1 and right, down, excuse me, left, backwards from what you were doing. All right, there's my 2 lines. So, how many solutions do I have? They will have no solutions because same slope, and both the slopes were 1. So that means they will never, never, never cross. No solutions. Okay? Now, if it would have been 1 and negative 1, they would have crossed. That's not the same thing. They have to be exactly the same solutions, same signs and everything. And then they won't cross. Okay? All right, so that's no solution and a 1 solution. And that's all. So we will practice a lot in class. And if you have any problems, come see me. See you in class.